All right. Welcome back to Why Math Why. On another long hiatus. It's been busy, so I missed y'all. Well, today, coming at you with a great question that actually came out of Facebook. Huge shout out to my Facebook friend Dave for bringing this up on Facebook, and figured let's make a video about it. So Dave brought up this idea of 0.9 repetent, which means 0.9 repeating infinitely far. So, longer than I could ever write out. 0.9 ... In mathematics, that means 0.9 and never, ever, ever ending is equal to 1. And you might think, no, it's not equal to 1. That's 0.99999999999, which is not 1. Oh, but it is. And so the argument, one of the most popular proofs out there for this is an algebraic argument. I'm going to show you that first, and then I'm going to kind of conceptualize the argument and say why it makes, I think, some sort of sense, but it's still maddening for others. And this delves into a lot of really cool stuff. So without further ado, let x equal 0.9 repetent. So that number. Now, what we're allowed to do is we can multiply x by 10. And the reason why we would want to do that is that allows us to then multiply the other side of this equation by 10. So we're multiplying this side by 10 and that side by 10. That gives us 9.99999, right? 10 times 0.99999 moves the decimal point over one place. And then what we can do, and it's actually by this mathematician by the name of Carl Friedrich Gauss, this brilliant mathematician who said that we can add or subtract two equations that are both true. That's a true equation, that's a true equation. So we're going to do 10x minus x and 9.9999999 minus 0.9999999. The repetents are going to subtract out. And you're left with 9. So x, which is 0.9999999, is 1. And you might think, balderdash, this can't be it. Maybe you're not thinking balderdash, but you're thinking, no way does this make sense. Well, let me show you why I think this actually does make sense. And it all comes from this box. So we've got this box right here. And basically what I'm going to do is I'm going to show you how 0.9999999 will approach 1 as the 9s go out to infinity, which is what this basically says. It says that as 9s go out to infinity, we will end up equaling to 1. So you can actually write 0.9 repetent as 0.9 plus 0.09, like the sum of all its decimal places, plus 0.009 plus 0.0009 plus, and so on and so forth, until we go out to infinitely many zeros out to 9. So 0.9, this part right here, that would be 9/10 of this box. So this box represents, if you will, a 1 by 1 unit. So this would be 0.9 by 1. So that area right there is 0.9. 0.09 would be 1/10, right? If you will, that'll be 1/10 of what we just found right here. But now that's what we have left is 0.1. So we've got 0.09, so that's 9/10 of that. So right there, this part right here is 0.09. So this is 0.9. This is 0.09. And then 0.009, again, is going to be this amount of the 0.01 remaining. So this would be 0.009. And then we have another amount in here, 0.0009. And so on and so forth. So that amount is in there. And you see that we're never actually going to totally fill up this box. So you might say, no, so that means that we're not equal to 1. Au contraire. What that means is that eventually we fill up this box. We will. It'll just keep cutting down smaller and smaller until the amount of space, this space right here, is negligible. There's basically no space as we go out to infinitely many 9s. Meaning with no space left, we have filled up the area, which is 1 by 1. This is called proof by exhaustion, and it's one of the ideas piloted by another guy, Archimedes. So some of you might say, Eureka! This makes some sense. And those of you that have no idea why I'm saying Eureka, then that terrible joke was even worse than it first sounded. So anyway, that gives you a visual proof of what's going on. This is all a part of something called a geometric series. Geometric series are used in everything from harmonies in music to the physics of a bouncing ball to number patterns like this. So I hope that this was a really neat little introduction into the realm of geometric series. And if you don't know what I'm talking about there, at least it was something crazy to wrap your head around. And you might still say, you know what, I don't agree with you. 0.9 repetent does not equal 1. Well, you know what? Eventually it has to, because we're going to fill up this box as we go to infinitely many number of 9s. Hey, the argument goes on with this one, but hopefully I've convinced you at least to think about it a little more. Peace out. Hope that was helpful. Keep mathin' hard.